To bring this first sprint of Houdini in 5 minutes to a glorious end, I wanted to talk a bit about packed primitives and packed instances. What are they? If you look at this image, there are multiple ways of storing a cube in your computer's memory. And here on the left side is what we typically do, just storing 8 points and their connectivity to form a cube. However, what we could also do is store this cube and its 8 points somewhere in memory, and then store another single point and tell the computer to quote-unquote copy the cube that's stored somewhere else onto this point. And you might say, well, this is kind of inefficient, right? Because storing 9 points and a link to a cube over 8 points is more involved. And yes, you're right. However, if you're working with multiple copies of this cube, this initial disadvantage quickly disappears. For example, in this case, where we're looking at 6 cubes. So on the left side, we are just storing those 6 cubes as they are. 6 times 8 points, storing 48 points. However, on the right side, we're doing this instancing workflow, where we're just storing 1 cube and then use points to tell the computer where to look up the geometry that's on those points. And this is what packed primitives is. So in this case, we store 1 cube, which is 8 points, and then 6 additional points, which is 14 points overall. So just with those 6 copies, we reduced our memory footprint in this very simple and slightly inaccurate example from having to store 48 points versus having to store 14 points. And the difference, of course, gets bigger the more copies you have. Alright, let's demonstrate that in Houdini by dropping down a sphere, diving in there, and setting this to be a polygon, maybe increasing its frequency to 8. I'm gonna zoom out a bit. And then I'll just drop down an ISO offset to turn this into a volume, and then again scatter points into this volume, in this case 1000 points. And then I'll drop down the copy to points that we already used in the very first tutorial of this 5-minute series, and I'll wire in a pig head to be copied onto those points. Let's dial back its scale to say 0.05 and wire it in and highlight the copy to points. So that took a short while, and now we can see those individual pig heads and everything is fine and dandy. So let's increase the points here to say 8000. And this now took quite a while. And also, when we are moving in the viewport, we can see it starts getting laggy. So instead of just taking this pighead's geometry and stupidly copying it onto those points in memory, generating, in this case, over 23 million primitives, let's, in the copy to points, just check pack and instance and use the instancing workflow instead. And immediately you can see this was a bit quicker. We are seeing those weird gray boxes. When we are middle mousing on the copy to points, we can only see 8000 primitives here. And when we move around in the viewport, that feels also a bit less laggy and a bit quicker. These gray boxes here are Houdini's built-in visualizer, so Houdini assumes that when you are working with instances, you're usually working with a lot of them, and to keep your viewport snappy, Houdini just replaces your instance's geometry with its bounding box at a certain distance. And if you don't want Houdini doing this, you can just hover over the viewport, hit D, go to the Optimize tab, and uncheck distance-based packed geometry calling. So we're ending up with this here. Not only will your viewport in Houdini be more performant using packed instances, but also your node tree will execute faster, and of course your rendering will be quite quicker. And most render engines inside of Houdini, be it Mantra, Redshift, Octane or Arnold, can work with those instances. However, what's a bit cumbersome is to transform those instances, namely rotations, because this quickly leads to you having to deal with quaternions or matrices, which are not always as intuitive as a single vector or 3 rotation angles. And to help you cope with packed primitives and instances, and also to give you another set of tools for creating generative graphics, motion graphics, there's this tool called MOPS, Motion Operators for Houdini. As a full disclaimer, I was part of this project when it started. However, for the last 1.5 years, Henry Foster, aka Toadstorm, is doing a brilliant job of developing, maintaining, and extending this toolkit. And I just want to use the following videos in Houdini in 5 minutes to show you some of the neat tricks you can do using MOPS. If you guys like what we're doing and want to support us, you might want to head over to our Patreon, and we'd like to thank all of our patrons, especially Refik Anadol, Chris Hebert, Important Looking Pirates, Encore VFX, Patrick Fillion, and Gearbox Studio Quebec. Thanks so much, guys.